Hello and welcome to TCAT Centaurus video tutorial, Centaurus Structure Editor, Section 3, Generating Doping Profiles. In this video, we will use the structure of the 2D PDSOI device that we have created in the previous episode and define doping profiles. In the subsequent video episode, we will go over mesh generation. Doping profiles are defined on the nodes of the finite difference mesh. Therefore, until the mesh is constructed, we will not be able to see the doping in the structure. At this step, we will only define the doping. It's worth mentioning that natively, Centaurus Structure Editor operates on the boundary only. Mesh generation and doping profile creation is performed seamlessly by Centaurus Mesh using the definition in the structure editor. Here is the structure with the doping that we are going to define in this tutorial. Silicon substrate and epitaxial layer have constant doping. Source, drain, and extensions are defined using Gaussian functions. It's time to begin. First, let's start a new session of Structure Editor by typing STE in a command line. Open a model that we created in the previous episode. Notice that we are loading an SAT model file and not ETDR boundary file, as the former contains all the information necessary for a restart. To rotate the structure, change the camera view. We start with the simplest definition for silicon substrate, a constant profile placement. Open Constant Profile Placement dialog. To define a profile in the entire silicon material, we choose the appropriate placement type. Boron is doping species and 1E15 concentration. Next step is defining doping in silicon epi layer, also using constant profile placement dialog. You notice that the dialog displays the previous definition and the button reads change placement instead of add placement as before. We need to change the name of the profile placement to avoid overwriting the previous definition. To start with doping in the epi region, we can use region name. Right-click on the geometrical entity gives information that includes region name. Notice that region selected for placement is also highlighted in the model view. We also need to change profile name to avoid overwriting previously defined boron profile. Boron is a doping species and concentration is set to 1E17. The placement of an analytical profile is performed in two steps. First step defines the baseline, and the second step defines the properties of the profile itself. The baseline serves as the reference point for the depth of the peak position and determines the lateral extent of the profile. We are going to define a total of 4 Gaussian doping profiles, 2 for source drain and 2 for the extension regions. Before we start with the source profile definition, we need to check that the exact coordinate mode is turned on and auto region naming mode is turned off. In this mode, program will prompt user to enter the object names to make them more descriptive and easier to remember. First, we create a baseline for source profile, choosing line object in reference evaluation window option. Start the line outside of the structure to ensure that the Gaussian decay emulating lateral diffusion doesn't artificially change the profile inside the structure. Next, we define source profile characteristics and placement. Open analytical profile placement dialog. We need to give profile placement a unique name. Since only one reference object is defined so far, source baseline is automatically chosen. Source and drain profiles have identical dopamine characteristics and can share the same definition. We enter the name, species, peak concentration, and position, and depth characteristics. Positive direction means that the profile will be only created below the reference line. Source profile is defined. We now repeat these steps for drain baseline and source drain extension baseline definitions. To define drain profile, we need to provide a unique placement name and choose the correct reference line. However, the profile definition can be reused. In a similar way, we can define extension profiles. First, the source extension, where the profile needs to be defined. And next, the drain extension, where the profile definition can be reused. The only remaining step is to save the model. This concludes the video. In the next video, we define a meshing strategy and generate mesh for this PD SOI device. Thank you for watching.